Okay, and welcome back to Supernova Labs. So, what I wanted to talk today about is a little bit more about Supernova Labs, the Open Spaceplane project, and where the whole thing comes together. Because I've spoken about container labs, and I've spoken about open source space planes, and like how do these two things go together? Like what planet is this going on, right? Like what? Why would you want to build open space planes and also build like these labs? Because they're kind of two completely different things. Like they don't really go together. But if you hang on, I will explain to you exactly how that's going to work. So, the reason why I've been talking about Supernova Labs as container labs is because we want to build a network of these labs worldwide to gather the data to manage existential threats to the planet, such as climate change, such as like political discord, such as civilizational breakdown, like making sure that the information is stored in a decentralized network at least to manage the decline, like in the same way as the Foundation was set up to in Asimov's novels. And the spaceplane element is pretty fundamental to that because this all hinged on logistics in a resource-based economy, and having the data is only one part of that. Being able to move materials, people, infrastructure around at the speed, well, at the fastest speed possible, is going to be absolutely vital for managing these, like specifically climate change, for example, or like space debris and managing the impacts of that. So, like being very responsive is going to, well, we need to become hyper responsive in the future. So I have a meeting with the International Space University in the next week or so, going over plans for a lunar village, and their new project is towards a lunar generation with the Moon Village Association, and I'm quite grateful to have been included in the founding meetings of that. Now, my reasoning for pairing space planes and these labs together is because I'm trying to set up a model for space colonization. And this is the reason why I want to have labs completely off-grid and connected to satellite internet versus like using conventional infrastructure, because I'm assuming that you're going to be going into an environment that is completely hostile to life, that only really has raw materials to work with. So how do you bootstrap a colony or a society in those conditions? And what you need is hyper responsive transportation. So this is the reason for open space planes and spacecraft in the future, and also the means to build and work and thrive in environments that are hostile to life. So if you can approve that model on Earth first, it becomes a lot more viable to do it in space. So this is maybe the disconnect I think a lot of people have been having with Supernova Labs Spaceplane project. Why are these two things go together? Like, I think that they're mutually independent. Mutually interdependent. And that's why I am doing what I'm doing. Now, in terms of space colonization, like we're still like a way off from it. I think people underestimate the amount of steps we need to get there in the first place. I mean, it's all great going back to the moon, setting up a lunar gateway, having the means to get back down to the lunar surface and setting up a permanent presence there, but what about low Earth orbit? Like, you're going to have to commercialize low Earth orbit in a meaningful sense. So there are private space stations, and the International Space Station is looking to maybe integrate some more commercial aspects into what they're doing. But until there's like a model and an economy in low Earth orbit for what is going to be produced on the moon, I'm talking like to medium term here, it's not going to generate the same amount of revenue to develop cislunar space with the infrastructure for like refueling, for uh, like transit, and like all the administration that goes involved with transit, setting up trade routes along Lagrange networks. So you can kind of take the Lagrange points of each body and work out the lowest energy routes to take to get between these bodies, and you can kind of orbit these pathways effectively, or trade routes. To go into a little bit more detail about space economics and how to set up an economy in low Earth orbit, a lot of what we've been trying to work out in that first space lab in Dalston was, what are the tangible steps you can take to get a space economy going, right? So I think a lot of it hinges on water, firstly, because I mean, having been born in a desert, like, you understand the value of water, and you need water. Like, water is kind of the genesis point of all life in the universe. Like, with water, you can separate it out for fuel, you can separate it out to breathe, you can separate it, well, you can use it to grow plants and food in space. It's pretty fundamental if we want to be increasing the number of people on orbit, and that is my metric, and I think it is now beginning to be adopted as the metric in industry as well, that the number of people in space is probably the most important metric at the minute. It's like, if you can get people up there, they need things to do, and there are lots of things to do in space, like from manufacturing to biotech to like infrastructure development to research to like managing commercial space stations, and like all the hospitality elements of it, if you're talking about hotels and bringing customers up there, space flight operations, all that. So we need to start thinking about how this economy grows, right? So you've got water, you have, well, where are we getting water at the minute in space? Like, there's only one major trade route at the minute for water to orbit, and that is from Earth to the International Space Station. So with it in mind that the International Space Station is taking a more commercial element, one of the plans we put forwards for commercialization of the International Space Station, alongside the new docking port that they have for CubeSats and launching CubeSats and maybe receiving CubeSats as well, is that you kind of extend out there are like bubbles around the International Space Station. They're like kind of keep out zones, and like when you're approaching the space station, you get to this keep out zone, then you're allowed to come into its airspace before finally docking. So generalizing that more so that CubeSats can use that, and can use the space station as a service station and refueling station if needs be, where there are people actually like fixing the CubeSats and like actually refueling the CubeSats manually, I assume, in the beginning, and then eventually automate it. That then creates a bubble around the International Space Station that becomes an operable volume for completely reusable CubeSats, and then you can do missions like on that basis. Now, this is where it ties into space junk, and this is, I think, probably one of the most important points, that space junk is becoming an enormous issue, and it's catching up with climate change as being one of the primary existential threats to civilization, just on the basis that the number of collisions grows exponentially. And as a result, you end up with like entire orbital planes that you can't use. Going back to this volume, that becomes a operable bubble around which these CubeSats can maybe be designed to a standard that uses water as a fuel source. And if you're interested in specific companies that are doing that, there's a company called Steamjet that is utilizing a steam boiler as the reaction mass, steam as the reaction mass for attitude adjustment on orbit. You can then have a then have a system where CubeSats can get fueled and serviced at the space station, but then can go out and fetch bits of junk to bring back to the space station, so we're not losing the value of deorbiting all this hardware. And I think this is one of the biggest concerns I have with a lot of the dealings with space junk at the minute. Is it's all about deorbiting, and you've already spent millions and millions of pounds a kilo to get stuff into orbit, so there's value on that material being on orbit in the first place. All you need to do is centralize it back to the space station or to another space station. And as a lot of these companies are building fuel depots, you can start to think about volumes that are strung together, so you end up with bubbles all around different orbits that you can move between and start plotting out routes for collecting junk and bringing it back, and you can mine low Earth orbit for high value materials. That would be my primary way of commercializing low Earth orbit if that were the case, which then opens up the moon, cislunar space, fetching larger pieces of debris like spent rocket boosters, repurposing them as platforms that CubeSats can interact with, or maybe even people can live in if they're still up to scratch. Like, that's more like the kind of like space punk kind of independent operator kind of vibe in the future. I don't know whether that's possible. Well, anything's possible. So let's see. So that's pretty much it. I think one other thing that we were talking about with the Open Spaceplane project is developing a lunar operating system. So some cryptocurrency based operating system for managing APIs between different service providers that come over there, and setting up a standard for that. That's kind of been sitting dormant for a while because, I mean, without any real infrastructure up there, any real need for APIs to work together on a service basis, I mean, there's no point in developing it yet. But it is on the cards. So with that pretty much lays out all the bits that we're looking at towards space colonization, like how all these bits begin to fit together in the future, so that when people are asking, well, okay, then why put these two things together, there is an effective answer now. And with that, I appreciate your time. Thank you very much for listening today. I hope you have a good day.